So we'll start in couple of minutes, so others will join. Hello. Hello. Am I audible?
Yes, sir.
Yeah. So hi everyone. My name is Iren Solanki and I welcome you all for this problem solving session of Geographic Information Systems week 8. I am currently a PhD scholar at Department of Earth Science, IIT Gandhinagar, working in the application of machine learning based flood forecasting. Now, in this particular week, we have learned about various methods to generate DEM data and various kinds of resolutions which are available within the raster data. So we will explore it as we do for the other lectures. First, we'll take a quiz and answer some questions regarding the topic which we have learned. Then after, we will explore some of the data sets, particularly today we'll talk about the data of biodiversity. And then after, we will do some mapping within the GIS software such as QGIS. So with this, let's get started. So we'll start with solving question first. So I hope my screen is visible to you. Yeah. Is it visible?
Yes, sir.
Yeah. So, okay, let's get started. So the first question is, which of the following is not a recognized method for generating a digital elevation model? Option A, photogrammetry using the stereo pair images. Option B, radar interferometry, INSAR. Option C, thermal infrared based estimation. And option D, sonar.
Option D, sir.
Yes, so sonar is not a like it can be useful to generate the bathymetry of oceans, but currently it's just only for ocean part only. So correct answer here is option number D. Next question is, which DEM generation method relies on physical site presence rather than remote sensing? Option A, LIDAR. Option B, topographic surveying with total station or GPS instruments. Option C, satellite stereo images photogrammetry. And option D, SRTM radar data.
Option B, sir.
Yes, so here we have to go to site and do the survey, and that's why the topographic survey. And then after, we will generate the topo sheet, which has contours in it, elevation at some locations, and we will using that we will generate a topographic map. Okay. The next question is, the NVSat mission utilized which primary instrument for elevation-related acquisitions? Optical stereo cameras, radar altimeter, thermal infrared sensor, or laser altimeter? So this is one of these four are the methods for collecting the DEM data through by the means of remote sensing. And NVSat is one type of satellite which we use. So that is a part of a radar data acquisition in which we use the radar altimeter. The next question is, which satellite is specifically noted for having a payload of two cameras, one near nadir looking -5 degree and one forward looking 26 degree to generate stereo pairs? Sport, Cartosat, Terasar X, or Esther?
Option B, sir.
Yeah, so the correct answer here is a sport. So I will show you both of the data thing in slides also so that you get some sense of site as well. So here for the previous question where we highlighted the NVSat. So NVSat is a radar data pairs. Data pairs means it uses the concept of radar and it uses the two different imagery at two different time interval, and based on that it generates the elevation data sets. So it is based on the SAR interferometry. And Sentinel-1 and NVSat are the type of, apart from that radar set is also there. Now for stereo pairs, we have Sport Cartosat, which uses the concept of stereo pairs. They click the images from two different angles, and from there it generates the DEM data. Whereas thermal infrared data, where our primary hypothesis is that elevation temperature is changing with elevation and both are inversely proportional, and based on that we generate the terrain data, and lidar data is based on the lidar detection. So basically the light will go, like basically laser will go and come back, and basically measuring that pulse will find the elevation or the location of the different points and generate a 3D models. So these are the pi, and then common method is using a topo sheet, where you use different instruments, and then based on those instruments you connect a topo sheet and then correct the DEM data sets. And now this is, so here for the next question we had this data sports satellite. So sports satellite is 27 degree east or west. It has a viewing at 27 degree. Whereas if we take example of Cartosat, which is an Indian satellite, so there you can see it has a payload consisting of two cameras, one with nadir looking -5 degree and another with forward looking 26 degree, both of which provide real time stereo data along the track with a spatial resolution of 2.5 meter. Okay, next question. Any doubt till now? Okay, fine. Uh, Next question is, what is the correct workflow for generating a DEM from a hard copy topo sheet? Option A, georeferencing, interpolation, digitizing, scanning. Option B, scanning, georeferencing, digitizing, interpolation. Option C, digitizing, georeferencing, interpolation, scanning. And option D, scanning, interpolation, georeferencing, digitizing.
Option B, sir.
Yes. So first of all, we will take a map, scan it, and then we'll do the georeferencing, and then we'll digitize the object, and then we will add, if we have another data of from GPS, we'll combine the data with the data available in the map, and then we will do the interpolation. So if you see the correct workflow for this particular process, then it looks like this. So topographic map preparation, then which is using surveying instruments, then scanning of that map, georeferencing, digitizing, and then we from the digitization. So basically what we will digitize from that maps. So in topo sheets, we have different points marked as elevation. Okay, and then some contours are also there. So I mean, let me show you some of the maps, topo sheet maps, so you will get more idea, right? So these are the few maps which are available if you are interested in looking out how this topo sheet will look like. So this map is from Gujarat in the area of Banaskantha, and like once the survey of India do the intensive survey, then this maps looks something like this. So here, if you zoom in, you can see different location where the dots are mentioned, and it will show the elevation value at that location. So basically we'll digitize this elevation values. Basically it will create a point data, so it will have x, y and z value. And apart from that, at some locations you will also have the contour line. So to know about that, you should refer to the legends which are given here, and based on that you can get an idea of the points and what does it represent. So there are particular benchmark stations are also there which we use when we do the survey. Okay. And I think in previous class someone was asking about scale. So I think we'll come back to this later on once we finish all the questions, and we'll really see how to read this as well. Okay, so the correct answer here is option number B. First, we'll do scanning, georeferencing, digitization of points and contour lines, and then after the interpolation will be carried out. Next question is, spatial interpolation is defined as a procedure of removing atmospheric noise from satellite imagery, estimating values at unsampled site within an area covered by existing observations, calculating the distance between two contour lines, or creating a 3D surface into 2D map projections.
Option B, sir.
Yes, so that is the correct answer. The next one is, why is grid or raster representation of surface considered the most functional one for engineering analysis? Option A, it is the only way to represent discrete object. Option B, it facilitates easy mathematical operations and neighborhood analysis. Option C, it stores only a single Z value as opposed to multiple Z values. And option number D, grid cells are always more accurate than team triangles.
Option B, sir.
Okay, so that is a wrong answer, because the correct answer here is, when we are talking about functional surface, it should have only one Z value associated with X and Y. And that's why it makes it unique and not the redundant. And that's why it's a functional surface. So correct answer here is option number C. I'll look into PPT as well, so you will get more idea of it. Um, so I think you can see here that surface representation in simple form is done by storing XYZ value that defines the location of a sample. Now, in this case of contour line representing elevation, it is a line drawn on a map that connects point of equal elevation, and then a triangular irregular network is a vector data structure. Team partitions the space using irregularly spaced XYZ values. Then these points are getting connected. Uh, yeah, you can see here that a grid representation or raster representation of a surface is considered to be functional surface because of any given xy location. It stores only a single z value as opposed to the multiple z value, and all these functional surfaces are continuous in nature. Okay. Next question is, identify the true statement regarding the surface type in GIS. Terrestrial surface represents the Earth's physical terrain. Mathematical surfaces are generated using arithmetic expressions. Static, Statistical surfaces can represent demographic data like population density, or all of the above.
Option D, sir.
Yes, the correct answer here is all of the above. The next one is, identify the true statement regarding the team or triangular irregular network. Team partitions the geographic space using irregularly spaced data points. It can utilize both randomly and regularly spaced input points. Team is a topological data structure, or all of the above are true.
Option A, sir.
So option A, yes, it is right. Team partitions the geographic space using irregularly spaced data points. Then what about B? Because here the last option is all of the above are true or not. So we have to check that as well. So it can utilize both randomly and regularly spaced input points. So yeah, that is true because in TEAM there is no such limit that you have to use randomly selected point or you have to use regular point. If you have grid like point also, TEAM algorithm will work. Okay, so that option is also right. And considering that, our answer will be D because all are above. All the above, all of the above are true. And TEAM is also topological because things are connected with edges, face, each triangles. The next one is which model is specifically referred to as a bare earth model having removed buildings and vegetation? DGSM, DTM, TIN or DVM?
Option B, sir.
Yes, so it's the digital terrain model. And we have digital surface model which just show the surface. Correct answer here is B. The next question is which method is characterized as the most time consuming yet provides the highest accuracy for small scale projects? Stereo-states photogrammetry, ground-based topographic surveying, contour interpolation, and radar interferometry.
Option B, sir.
Yes, so we do a survey using a total station, robotic total station, GPS, or some instruments like that, which will give us the very high accuracy rather than interpolating the data from contour sheets or doing a satellite-based estimation. Because for small-scale projects, satellite data will not be enough, or that might be very costly, adding a lot of component in a post component in the project. So that's why we do prefer a land-based survey, terrestrial survey. Which of the following is common technical problem associated with interpolation? Edge effects at the boundary of the study area, visual representation inaccuracy due to poor sample distribution, failure to capture extreme high and low points, or all of the above. Any idea? So here the answer is all of the above. Are you guys able to hear my voice?
Yes, sir.
Okay. So here the answer is all of the above. Why? Because if we do not have some points near to the edge or some points are missing in between, we will have edge effect because where the points are there, it will show some data and then we see a different like gradient or some edge kind of boundary kind of things in a when we do the interpolation. Then visual representation inaccuracy due to poor sampling distribution. If samples are not distributed evenly, then it will create a wrong visualization because like it will just interpolate in between, which will create a very wrong surface there. Then the next one is failure to capture extreme high and low points. So if there is a peak or valley or deep point or high point, then we are not able to capture because it is just out of the surface or extreme points, which is known as an outlier as well. So these three are the problem associated with the interpolation. The next question is, which of the following satellite is not typically used for generating a global or regional DEM products? Cartosat, Landsat, Aster, or Allostrism? So the correct answer here is a Landsat because Landsat has the optical data and with the optical data we cannot generate the DEM. However, by using the thermal band of Landsat, we can use the thermal infrared based methods to get the elevation, but that is still not typically used in the like domain. So these three are directly gives the data of elevation. Cartosat using the stereoscopy or photogrammetry and esters and then allows pulsar, which are also ester is 30 meter, cartosat is like within the range of less than 5 meter, and allows pulsar is around 12.5 meter. The next one is, which of the following DEM products is generally associated with a lower spatial resolution compared to others? Cartosat 1, SRTM, Allos Prism, or Sport 5?
Option B, sir.
Yeah, so SRTM has 30 meters, whereas all the other has less than like Allos Pulsar is 12.5, Sport and Cartosat like less than 5 meters they have. So correct answer here is SRTM. The next question is, what is the standard look angle used by the Sport satellite to generate stereo pairs? 10 degree, 27 degree, 45 degree, 90 degree, nothing only.
Option B, sir.
Yes.
Option B.
So correct answer here is option number B. Next one is, which of the following is not a radar-based satellite system? RadarSat 1, TerraSAR X, Sentinel-2, or NVSat SR?
Option B, sir.
TerraSAR, so in that name only, like these three of them are representing SAR or radar. So they are like SAR means synthetic aperture radar, which is a radar-based system only. Okay, so option B and D are for sure radar based. And the first one is RadarSat, which is also based on radar. Sentinel-2 is optical satellite. If you talk about Sentinel-1, then it is SR data, but Sentinel-2, it's a optical satellite. So correct answer here is option number C, Sentinel-2, which is an optical satellite, not the radar-based satellite system. Which technology is capable of providing the highest resolution DEM for urban infrastructure analysis? SAR, LIDAR, thermal remote sensing, and topographic detection.
Option B, sir.
Yeah, so LIDAR is the correct answer here. Just give me a minute. You just read this question. Sorry for the delay. So our next question is, a hill-shade representation of the first written surface is known as a DEM, DSM, DTM, or all of them.
Option yes, sir.
Option A. No, the answer here is option number B, DSM. So, like DEM is a very general term which represents overall digital elevation model. It's not a specific term, but you want to specify what do you specify properly, whether it's a bare earth or a first return. First return means the above surface also, such as a surface of tree or a building. Then it is a DSM, which is a digital surface model. And as the name suggests, it is a surface. So it will be first return. So correct answer here is DSM, not the DEM. So when we eat Maggi, like there are a couple of brands which are available, but we termed all of them as a Maggi. So the like similar to that, DEM is very general term, digital elevation model. But now what do we want to present, whether the surface or terrain? Based on that, we specifically use DSM or DTM term. So DSM is a first return, whereas DTM is a bare earth model. So in that, the correct answer was DSM, which was the first return. The next question is, what is the fundamental assumption behind the thermal remote sensing based elevation estimation? Temperature and elevation are directly proportional. Temperature and elevation are inversely related. Temperature has no correlation with elevation, or higher elevation always results in a higher brightness temperature.
Option B, sir.
Option A,
B.
B, yes. Because it's like if you go up on mountains, you will feel cooler temperature. So both are inversely related. And based on that concept only, people use the elevation modeling considering this principle. So option number B is right. The next question, in thermal elevation modeling, the relationship between brightness temperature and elevation is typically linear in positive, non-linear in negative, logarithmic in positive, and or random. So first of all, it is inversely proportional, so it should be a negative. So the correct answer should be B automatically. And non-linear, it means it's not just varying with some kind of linear function. Okay, it varies some with some random function. So that's why the correct answer here non-linear and negative, because it depends on multiple parameter rather than just one parameter. So the correct answer was B. Next question. A major problem with free global DEMs like older SRTM or Ester GDM is the lack global coverage. They often contains voids or inaccuracy in steep terrain and over water. They cannot be used in commercial GIS software. They only store elevation in 1-bit radiometric resolution. So first we'll dissect one by one. So this SRTM, it provides a global coverage. We have also seen in the previous labs also while using that particular website, Open Topography. So this particular DMs provides a global coverage. So option A is wrong. Option D, like 1-bit radiometric resolution, it's very less because we cannot represent a lot of changing variations in the temperature. And that's why option D is also wrong. Option C, they cannot be used in commercial GI software. It doesn't like that. Like we can use if we have any DM product available with us, we can use it in GI software as long as it is a compatible file with the corresponding GI software, such as the .t for GeoTIFF file or estate file or any other file. So option C is also wrong. The correct problem is that they often contains voids. Wherever the water is there, it will not measure the elevation. It will just create a void or inaccuracy in steep surfaces and over water. The next question is spatial resolution in DEM refers to the number of pixels in the entire image, physical size of the ground area represented by a single pixel, the number of days between satellite revisits, or the range of wavelength the sensors can detect.
Option B, sir.
Yes. So size of the area that pixel represents on ground. Temporal resolution is best described as the vertical accuracy of the elevation values, frequency with which sensor revisits and records the data for specific location, the size of the pixel in XY dimensions, or the number of bits used to store data.
Option B, sir.
The frequency, how frequent we are getting the image. The next question is, which type of resolution refers to a sensor's ability to distinguish between different wavelengths of the electromagnetic spectrum? Spatial resolution, radiometric resolution, spectral resolution, or temporal resolution?
Option C, sir.
Spectral resolution, true. The next question is, radiometric resolution is measured by meter per pixel, the number of bits, nanometers, or days or week.
Option B, sir.
Yes. In the context of DEM, okay, I think we'll now check the different resolution first in the PPT so you will get some more idea because those are very general terms everyone should know. So basically, like when we talk about resolution or spatial resolution, it gives us the capability to identify the presence of two objects. So whether we are able to distinguish between two objects, so if two cars are remaining, like staying on the ground, are we able to resolve it using the satellite data or not? Capability to identify the properties of the two objects. Okay, so that is spatial resolution, and spatial resolution can vary in horizontal and vertical directions. So here is the example of spatial resolution. So here you can see like you just have one pixel, one by one. Then you make it to 2 by 2 pixel. So it will look like this. Then you are making it to 5 by 5 pixels. So you can see in center you will able to see some of the figure or some of the contrast is present. Now if you see in by 10 by 10, so you can see the shape. Okay, now you can see the 20 by 20. So now you are able to see the edge and how it is distinguishing from the previous background. Here the image are becoming more clear, and as you are increasing again, then you will see the actual particular image or object present in the given box. So here you can see how we are going from 1 pixel to 100 pixel, how it improves the image accuracy. But at the same time, it improves, like we have to store this data at every location. So the data storage will also become high. On top, you can see the precipitation patterns which are presented here, which is it. The one is very high resolution, something as a 5 kilometer or 10 kilometer. Then here you can see at 30 kilometer, and then here you can see at 100 around roughly 100 kilometer. How does it look like? So this is, I think, we'll go to resolution only directly. So spatial resolution, as you can see how clearly we are able to see the image, whether we are able to see clearly or is the image available blurry to us. Now here you can see 30 meter, 10 meter, 30 meter and 80 meter pixel resolution. Now the thing is we have not changed the pixel size like 10 meter per pixel. We have kept that same, but still you can see it's changing. So basically it's a like you as you go decrease the resolution from 10 to 80, the image will become blurry. So the next one will be, so spatial resolution is based on the concept of field of view, how much area we are able to see. Mm, So these are the currently available some DEM products such as SRTM, GDEM, Sport, World DEM, Elos Prism, GeoDEM2, Econos, and their spatial resolution. So SRTM is 90 meter, 30 meter product is also there. GDEM or ST is also available at 30 meter. Sport is available at 20 to 30 meter. World DEM is available at 12 meter. Elos says at pi 5, GeoDEM at 2, Econos at 2, and WV or GeoI at 1 meter resolution. And the accuracy also, vertical accuracy, you can see from here and whether it's available or not across your area, which area it is available. So apart from this spatial resolution, we have uh, temporal resolution, which shows how frequently we are getting an image. Suppose flood came, and then whether we are able to get image before flood and after flood or not. If we are able to get, then we can do the flood damage assessment. With same thing with any other event we can think of. Then radiometric resolution is means what is your sensitivity of your pixel to capture the brightness, different brightness values or the ranging brightness value. So it will depended by the bits. So higher the bits, higher the radiometric resolution. Currently in free satellite data, you will expect 12 to 16 bit radiometric resolution which they are supporting and sharing with everyone. And then we have spectral resolution. So how many electromagnetic spectrum bands we are using in a satellite? If it is 8, then it is known as a multispectral remote sensing. If it is 2, then monochromatic or panchromatic remote sensing. And then when we have more than 10 bands, such as we are having in hyperion, then it will become a hyperspectral data and we can generate a very smooth spectral signature out of it. Okay, so moving towards the next one. In, in the context of DEM, which statement regarding resolution is generally true? Improving spatial resolution typically increases file size exponentially. There is no trade-off between different types of resolution. Spectral resolution is most important for DTM generation. High temporal resolution is only possible with higher spatial duration.
Option A, sir.
Yes, so increasing spatial resolution will increase the file size exponentially. Next question is comparing vertical resolution and horizontal resolution in typical satellites (DEM). Which of the following is true? VR is always higher than HR. HR is usually higher than VR. Both are always identical. Satellite sensors cannot measure VR.
Option A, sir.
So here, like, it is not right. Why? Because when we measure the data, we can measure the XY locations very easily and precisely. Whereas it comes to measuring Z, it's very difficult because we are having a lot of error if we use GPS, and the errors due to GPS are also introduced. And because of that, like HR is usually higher than VR. And considering that horizontal plane is more precise. Option number B is right here. Next question. Which term describes the likelihood that a particular set of measurements falls within a certain range of a true value?
Option B, sir.
Yes, so correct answer is accuracy. Filling the blank is a statement of the smallest unit of measurement uh, to which data can be recorded. Accuracy, precision, lineage, or completeness.
Option B, sir.
Yes, so it is known as a precision. And are you guys know the difference between accuracy and precision?
Yes, sir.
Okay, so those who don't know, I will just reiterate it once regarding the difference between these two, showing a figure. So here you can see, like if we have high accuracy, then points will be nearby, and if we have high precision, it will be nearby as well as concentrated at one location only. Then we have high accuracy. The accuracy is very high, but the predictions are very low. Then you can see it is spreading across different location. Then you see the example of low accuracy and high precision. So every points are precisely marked over here, but they are very far from the object, and that's why the accuracy is less. And here you can see the accuracy is also not there and precision is also not there. The next question is fine resolution DEM offer greater precision, though not necessarily the greater accuracy. True or false?
True, sir.
Why? So the reason is we are using very fine resolution DEM. So it can match with the values very well, and that's why the accuracy will be very high. But sorry, precision will be very high because we are measuring at very local scale or very fine scale. But the accuracy will not be always high because precision is like what is your the list count of your instrument. Whereas how well you are measuring that object, that is dependent on accuracy, and that's why the correct answer should be true. The next question is to accurately represent a feature, the spatial resolution should be at least filling the blank in the size of the feature, equal to half, double, or 10 times. So the correct answer, it should be half, and half also compared to the minimum dimension of the object. So if you are measuring dimension of this bottle, let's say, okay, so considering this as its minimum dimension, we will do the half of it. So if it is, let's say, 10 centimeter, so that minimum resolution which I need to measure this bottle is 5 centimeter. Now, next question is which of the following derivative of following is a derivative of a DEM? Slope, aspect, view shed, or all of the above?
Option D, sir.
Yes, so all of the above is right. The next question is age effect in interpolation occurs because of the software caches at the study area boundary. This is a lack of sounding data points to constrain the interpolation algorithm. The spatial resolution is too high or radiometric resolution is too high.
Option B, sir.
Yes, so surrounding data are very less, and because of that, it will create a edge kind of structure. The next question is which of the following is true? Photogrammetry is only useful for taking photographs and does not yield quantitative data. Option B, GIS stores partial data only in the forms of images and files and has no linkage, database linkage. Option C, photogrammetry can only be used for capturing two-dimensional data points from aerial photographs. And option D, orthophotos produced through photogrammetry are geometrically corrected to have uniform scales and can be useful as a map.
Option D, sir.
Option A, okay, D, why orthophotos producer through, yes. Next one is a surface that is continuous and where every location has unique Z value is called as a discrete surface, functional surface, chain surface, random surface.
Option A, sir.
Yes.
sir. Yes, sir.
No, it is known as a functional surface. Okay, we have seen in the PPT as well. So that is known as a functional surface, where it is a grid representation known as a functional surface. These are continuous surface and has only single z value as compared to the multiple z value at a given location. Okay, so because of those reasons, it is known as a functional surface. The next question is find out the correct statement. Photogrammetry empathizes geometric accuracy derived from stereo imagery. Remote sensing empathizes spectral analysis from sensor data across different wavelengths. Both photogrammetry and remote sensing are limited to passive sensors, or remote sensing cannot be carried out by mounting active sensors like SAR data for acquisition. So photogrammetry is a way in a which we take stereo space, which is seeing one location from different angles or taking two photo and viewing that through stereoscopes, removing the parallax and using that we construct a DEM out of it. So the first statement is right. The another one is remote sensing empathize spectral analysis from sensor data across the different wavelength. So that is true, and that is known as a spectral resolution of a satellite. But depending on which how many bands it is representing, that's why the option number A and B both are correct here. The next question: which of the following is an active remote sensing technology? Sports stereo cameras, Ester, LiDAR, or Landsat thermal bands?
Option C, sir.
Yes, LiDAR is a correct answer here. The next question is the process of making a scanned map geographically correct in a space is digitization, georeferencing, interpolation, generalization.
Option B, sir.
Yes, so the correct answer here is georeferencing. What happens to the file size of a DEM if the spatial resolution is improved from 30 meter to 10 meter? It stays same, it decreases by 3 times, it increases by 9 times, or it increases by 3 times. So 30 meter to 10 meter. So how many number of pixel will be increased? So 30 meter by 30 meter, consider this as a 30 meter pixel, this one, the first one. So now we want to convert that into 10 meters. So what we'll do, we will divide it into 3 row and column wise. So how many pixel will it form?
9, sir.
9. So the space which we required to store these 9 values will be approximately increased by 9 times. So correct answer here is 9 times. C. The next question is the process of filtering in LiDAR processing is used to separate cloud from the ground, first written basically vegetation or buildings from last written, water from land, or x coordinate from y coordinate. So basically it's useful for first calculating the first written, option number B. A DEM stored in a 16-bit signed integer format can represent the approximately how many elevation levels? 256, 1024, 65536, or 32768. The formula here for this is 2 to the power n. So if you have 2 bit, you can have 2 into 2. So basically 4 values you can store, or 4 elevation levels you can store. So here the radiometric resolution is 16 bit. So you do the 2 to the power 16, and what will be your answer?
Option C, sir.
Yes, so 65,536 is the correct answer. The next one is radar interferometry in SAR relies on measuring the difference in filling the blank between two radar signals: color, phase, frequency, and brightness. So basically, we do measure a phase difference in the radar data. Next question is, which of this is a significant disadvantage of using contours to generate a DEM? Contours are too accurate, significant loss or information between contour lines. They cannot be used in GIS. They only show vegetation height.
Option B, sir.
So significant loss of information between contour lines, because we do not know how the elevation is changing between two contour lines, and that's why it will create an option in generating a surface. So option B is right here. The next question is, what is the primary raw material for generating a DEM using a manual photogrammetry? Radar waves, laser pulse, stereo pairs of aerial photographs, or GPS coordinates only?
Option C, sir.
Yes, so correct answer here is stereo pairs. And next and last question is, the scale is the ratio of the distance on a photograph or map to its corresponding distance on the ground, the ratio of the focal length of camera lens and flying height, directly proportional to the flying height, or inversely proportional to the flying height.
Option A, sir.
Option A is true. But here if you think either option C or D will also be right, as because they are both opposite. So if we go, like if we have same camera and if we go up, 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 so what will happen? It will increase the IFOV, and because of that, it will change the scale. So as we go up, the scale will change. So basically, the higher we go, the scale will it will decrease, like inversely proportional. So two will be answer. Correct answer here is A, but out of this one is correct. Now, so that was the question for today's. I will put this link and you will go through these questions in your PMRF portal. And yeah, I will. What I done is now you will get full questions all the time. So like you can just click on start now and you will get all the questions. So you answer by yourself. You can take the help of this video recording also if you don't get anything. And you just submit with whatever answer, it will show you the final answers at the end when you submit the button. Okay. Any doubt till now? Anyone? Any doubt? Okay, so if there is no doubt, I think one student have asked me about how we can read the scales. So I will show that. So first of all, when we refer scale, then it is a distance on map corresponding distance on ground. So here the scale is 1 raised to 50,000. So 1 unit in map is represented by 50,000 unit in ground. So if we consider 1 meter, then 1 meter in map is equal to the 50,000 meter on a ground. Or if you see if you convert this thing to meter or centimeter, you can consider that as a 500 meter to 1 centimeter. Okay. So high, like converting this into like converting this into centimeter and this into meters. Or what we can do is 1 meter, and this is how much kilometer, or basically if we convert this meter into centimeter, then the two zero will go out. So 1 centimeter will be equivalent to 500 meter. Or currently you can say is 1 meter is equivalent to 50,000 meter on ground, and which is equivalent to 50 kilometer. So if you see 1 meter, if you measure 1 meter in this map, it is equivalent to showing you 50 kilometer on actual ground. So that is how you represent this values. And then when this is given to you, so like now to interpret like how I identify 1 meter or 1 kilometer in a map, you can use this kind of map. So they have converted this scale over here only. So basically you use this thing 0 to 1, and you put the similar thing over here, and it will show you the 1 kilometer. Now sometimes we want to measure 1.1 kilometer or 1.2 kilometer. So that's why they are providing the sub kilometer level accuracy also. So here how you can represent it is, so this is entirely is 1 kilometer, which is further divided into 10 parts. So here you can see it's in a meter. So 1.1 kilometer, 1.2 kilometer, 1.3, 1.4, 1.5, 1.6. So if you compare this much distance, that is a zero point 0.1 kilometer, or you can say 100 meter in a map. So you measure with scale. Basically, this we used to do when we are having actual topo sheets, and with scale, rolling scale, we do this kind of thing. So is this clear about the scale?
Yes, sir.
Okay. Any other question regarding this? Okay. So now if you see any maps, you will see this kind of nomenclature, also G43, S7. So this is how ABCD is bigger window than 43, and then S7, S2, S3, like that. So if you are preparing for gate examination in geomatics engineering, you should know how the Survey of India is giving this naming conventions to the different different topo sheets. So that was the thing. Now, I mean, see, in this, you can also see the UTM zone which they are using. So currently, this particular map grid references are given in hundreds of meters of east and north, corresponding to the UTM zone 43 north. Thus, this reference system of this runnel is E233 and 2700. This is the particular coordinate reference system which they are giving. Here you can see the datas are in the geographic coordinate systems. But if you see some of the data sets, then it will be within the meters also. So you see here 2690000. So this represents the projected coordinate system, whereas this one is geographic coordinate system. So in this map, both are given together. So 2690000. So you can see 89, 88. So it is a changing like this. And once you change, it will become like this. So 2700000. Is that okay? So like this, you can read about the topographical map, and these are the different legends. So using that, you have to see. And now if you want to do georeference, you can take any of the corner, which is like, say, if you are taking this corner, it is a 72 degree, 15 minutes, and in X direction and Y direction, 24 degree, 15 minutes. And this is the entire topographic sheet. And here some information about what who did and all. And then here, if you see reproduction strategy, like units, scale, UTM projected coordinate system, what they have used. Then when this survey was happened, so this surveyed location is surveyed during the 1958 to 60, and major features are updated during 2005 to 2006. So you have to be careful about this thing also. If you are looking for the current detail, then it might not be a good idea to use this kind of sheets. Then higher in meter and above Indian sea level. So heights are in meter and above mean sea level. Contours are approximate. A relative height is given point eta represents the approximate height in meter between top and bottom of the steep slope. Then cart tracker in the sheet against the which there is no descriptive remarks are generally motorable four-wheel drive. A relative height against well indicates a total depth in meters. So well depth tank in this area usually contains water from July to April, and limits of cultivations are variable and depend on rainfall. And these are the further details about the price, Survey of India, the topographic locations, its scale, and other information. Okay. Hmm. So if you are interested, there are a couple of maps available on the Survey of India site, which are free of cost for Gujarat, Rajasthan, Punjab, Karnataka, Odisha, and Uttar Pradesh for particular locations. If you need to buy or download your own map, then you can go to this Open Series map, and then there are a couple of other maps are also available which you can download. So considering that, let's say Arunachal map. So you will get like this first of all, and then you will get to know what is a location or the naming of each and every grid which is falling within the Arunachal and which are ready for sale purpose. So this you can go to Nakshe portal or any other portal of the Survey of India through this link also, and you can download this. And here in addition to this, we are having a lot of maps available on Survey of India site, such as the political map of India, physical map of India, road map of India. So if some case you are interested in the data and you don't get from anywhere, you go to this site, convert your PDF from convert your data from PDF to PNG and try to digitizing it so that you will end up with the data. In case if you don't have any data and you want to do some work which is very important. So similarly, road map, railway map, India and adjacent country, world map is there, state map is there, tourist map, education map series, which we have seen here right, just before, outline map of India. So this also you can see how, what do you mean by outline? And you can see it's at various scale. So it's like this. Okay. And it's a various scale is varying. So you can see the accuracy of it as you zoom in. So this is the physical map of India showing the river and other physiographical parameters. Okay. Any doubt till this point? Anyone, any issue? Okay. So now today we will see one site which is known as a iNaturalist. So this is one of the application like which records the data of various species. So like it's a people-based participatory projects, and people have reported a lot of species data. And here you can see the density of the observations which are being made. So now if you are interested, like everything, like you have to take a photo using your mobile phone, then geotag that particular photo, basically keep the location on. So, and then after uploading this particular site along with the other observation, how that plant is looking or how that animal is looking. And then after you can just visualize it. So if you do zoom, just wait, it will take some time to load. So as you go high, you will see at which part the locations are like this observations are available. So if I go near to this Ahmedabad area, so like this is a classic example of what we have seen as a spatial resolution. So when we represent our data, in general, when we are seeing it at a very large scale, we use a very big resolution. And then as we go for follow or zoom in, then the size of the pixel will become small. And this concept which we have also learned during the pyramids. What are pyramids? So they are the different way how we zoom in, and according to that, how it shows the data. So basically, the idea is to fastly load the data when it is in lead. So again, we'll do. So now you can see now this is the final level. So where I reached. So this is data is a vector data, but as you go coarse resolution, this data looks like a raster data. So basically, it's a kind of aggregation is happening with the zooming which we are doing. Now, if I go down, you can see the legends. So basically, orange, blue, green legends are there. So now, if I click on any particular location, it will give me the idea about that particular animal or species which is there. So someone has reported this nilgais. Okay, and then other people also do the verification of the same, that whether it's an actual nilgai or not, or given elements animal or not. So basically, we'll go back. Similarly, we go here in the Gir forest. This is the grass from orange color, so that orange might be various plant species. Blue will be this birds, or we can see the legends also like this: map view, grid view, and list view. And these are the map legends. So birds, fish, mammals, reptiles, and other animals is shown by blue. Insect with the orange, plants with green, pink fungi, chromsia, and protozoas. So these are fungi. You can see this one is a bird, wood shrike, and then this is a fungus. You can see the more photograph of that particular species also. So if someone is interested in biodiversity mapping, they can do something like this, take in their area, and then they can just explore how does it look like their biodiversity around their place. Or they can use just directly this site and upload the data over here as well. And similar to that, we have another site such as India Biodiversity Portal. Or there also those who are associated with the biodiversity, they have given their data sets, manual, or their observations, which you can find from here. And here also a map tab is there, which you can use and see from where the observations are available. So here also, this is kind of similar to what we have seen, but these are the Indian data sets, so you will give more idea and created for research purpose only. So this thing, agar geology. So sometimes you will get a very high resolution vector data also from here. So if you will log into this particular site and you are interested in some of this data sets, you will easily download this vector shape files for you. Similarly, this other habitations of the same area where the people are living, their soil, watershed, wells. So whatever data some papers have used, and that the same data they have given here. Then you can see this is the forest division of Assam, then aquatic plants available in Western India. So you can see which are the plants. So yeah, this in this way you can download the data also if you log in into this page. And this is the way to show you the different type of biodiversity data. So if you are interested working with the fish, agriculture, any type of other species, mapping out their diversity, various how much area is biodiversity rich. If you want to do such kind of analysis, you can visit these sites in detail uh, for that purpose. Okay, any questions till now? Now what we'll do some analysis in QGIS. Just wait. Today I think we'll see some of the things doing so first of all we will open any raster layer into QGIS. Okay, I hope this is visible to all of you. Now first of all this is elevation data sets. We'll change the symbology of it so that we can visualize it properly. Instead of single band gray, black to pseudo band. So first of all, like when you don't know how to select this min max values, always use the histogram so that you will get the tentative range. So here I can see that my data is ranging. Most of the data are between the pixel value of 25. Okay, most of the data. And then so I can just, if I just uh, basically now if I see my histogram, let's say so you can see my ranges is like data is ranging about 2000 also, but most of the data sets which I have is within this window only. So 0 to 150. So I can try representing those layers only rather than putting all colors so that I can see more visualization properly. 0 to 150. So we can do that so that it will show the inside variation also. You can see here now it's become very good compared to the previous one. And now to make it bit good, make to 200. So you can see now this portion is white because they are like this area is kind of hill and then all of a sudden you can see the flat terrain. But you can see now the rivers and all those things are visible within these areas. So what we can do, we'll just clip some of the area. So how to do clipping of the DEM? The first task is raster extraction. So here we'll go to raster extraction. So extraction can be done using three way in QGIS. You can extract using the extent. You can extract using the mask layer. So if you have any other shapefile available with you, then you can use that shapefile also, or you can use your contours. So considering first we'll use the extent. So the data which I have and then extent I have to draw. So how much extent I want to. So I will go here and draw on map canvas. Let's say I will do something so that I can show this particular watershed. Okay, and then assign the specific no data. If there is no data value, so what to set here? So you can set either 0, 0, none, or if you do not set anything, you will just say as a no data. And then even advanced parameter, it will have whether you want to compress your data or not. So basically, uh, if you will save like this, it will save a lot of storage. So in some cases, if you are interested in reducing the size of your data, then you can select the this thing compression parameter also. So we'll just remove this parameter and then just click the data. And I will run my analysis. So the analysis is done and I got my data point like this. And now just forget about this. I will start working with this layer only so that it will take less time. Okay, so this is the data which we have. Okay, any issue till now, anyone? You want, if you any point of time, if you want me to repeat something or if you don't get anything, just please let me know. I will repeat the process. So here you can see these are the some of the peaks which you can see, and now which part it is representing. To see that, we'll just put the imagery behind of this. So it is representing this area, and like we'll put the Google Map image to get the labels. So this area is from the southern India in Kerala, and you can see the earlier one, the one which we had earlier, why it was not coming properly, because you see these are the mountain ranges, Western Ghats. So you can see here we are elevation is very high, and because of this mountains range, and then you have see this kind because of this is the very plain area. So here you can expect a lot of runoff because this will create a lot of volume of water when it will rain because the slope is very high. So the next target for us is how to calculate a slope or any other parameter for this particular area. So for that, so before like finding out anything, if we want to do any operation which includes the mathematical operation on raster data, we have to reproject it first of all. So here for raster data reprojection, we have a tool known as the WAP. WRAP. Now select the raster layer. Source is 4326 only, but target in which coordinate system you want to convert your data. So first of all, you have to see in which range your data lies. So it is from 76 to 76.28 to 76.38. Or here you can see 11.31 to 11.38. So this is the bounding box. Now I will go to target coordinate system, predefined coordinate system, and let's say we'll see the UTM zone 43 north. So this particular coordinate system is applicable when your data or the area of study is ranging between 0 to 72 or 72 to 78 and 0 to 84. So from latitude 0 to 84 and from longitude 72 to 78. And then currently what we are having here is 72 to 78. So it is within the region. Okay, and that's why we can go with this 43 north. So I will select that coordinate system, go back. So it got selected here. Now resampling method. So now it will reproject from one to another, and that's why it will do some mathematical operation, and that's why where the edge is there or in between, it has to calculate because this translation and rotation will happen, and because of that it has to do resampling to create a new surface. So which resampling method it should use? So generally we'll keep nearest neighbor as it will not alter the data more. Then no values, output file resolution. So you want same as the input file or you want to change the resolution of spatial parameter, then you can do that as well. Now we'll save it, clip extend in meter, and then so now you can see around the edges we are getting this thing black line. So we got some issue, and that is like why when we are wrapping, that's why the edge it will not have any pixel, and that's why this thing will happen. Okay. Now the thing is we have to calculate slope. So I will write slope, and then for slope you don't have to do much thing. Select the elevation layer which is in meter, and then just run it, save the file, and run it. So you got the slope. So now you can see where this you have seen this hills or the in between the elevation was high, this kind of hills. Obviously we will expect more slope at those locations. Okay. Now we will change the symbology of this slope. You can see the location with the higher slope and blue is with a lesser slope. Now the thing is the next task is here the slope value, it's in percentage, and you can see it's like from 0 to 39 percent slope is there. Okay, like sorry, 0 to 39. So now let's say we want to categorize that value into a classes. Basically this data which we have currently, it is a continuous data. The values are changing from 0 to 39. However, we want to convert this into a discrete data set. Discrete data means we want to make them into classified information, such as high slope, moderate slope, very high slope, steep slope, like less slope. So something like that. So for that, we have tool known as reclassification. So reclassification by layer and reclassification by table. So we'll use reclassification by table. So select the values and then you have to make a table. So the first thing is, let's say if it is from 0 to 5, then we'll say it as a mild. Then if the slope value is from 5, then moderate, then 10 to 15 high, 15 to 20 very high, and then last uh, we will use 20 to 40, which is steep, considering we want to do classification like this. Okay, now just save the value, in invalid output value for mild. Okay, so there is, instead of it we'll write 0.1. uh, 5.1. Okay. So what it is asking is that values are invalid, and the reason might be that we have given the values as a text values, but it might not be expecting a text value. That's why it is expecting the numerical value at the given value column. So we will write it as a 0, 1, 2, 3, and 4. Okay, so 0 to less than 5, 0, 5 to 10, 1, and then you can see these classes now. So these are from 0 to 4 only. And now here instead of we can use paletted value also, because now our data has some class only. So we can see these locations. Now it becomes clear that this particular patches have high slopes, and whenever it's a blue, it's a very steep slope. This okay. The blue one is the normal one, then moderate. Most of the are plains. And now let's say if I want to remove this 0 to 5, which is a very uh, like mild slope, then in that case I can just go here, then I can just reduce the transparency of this particular layer and click on OK. So it will remove that particular points from here as well. So like this it will do. You can see it now. So now it has removed those points where it was the 0 first of all. Now let's say we want to classify, like how we want to calculate the statistics of it, that how many pixels are in one particular class. So first of all, I mean, we have one thing that we can go right click, go to property, and then we can go to the histogram, and we can click on compute histogram. So 0, 1, 2, 3, 4, you will get the total number. But here, I mean, we have to go through it and check manually that how much value it's there. So instead of it, if we are directly needing the summary. So there are raster layer statistics or basic field statistics are there. So you can use the raster layer statistics, slope, and then we will just run. So now it gives us the one file which you can access, HTML file, and it will show what is the minimum value, no data pixel, maximum value, range, summation, mean value, standard deviation, and sum of squares. So this is just individual information, like average across the uh, pixels. Now, so if you have any other polygon, then you can use this raster NL zonal uh, raster in raster analysis, uh, zonal statistics. Apart from that, there was one more tool which was available. I'm not able to find it right now, but I will get back to you with this tool for getting the individual raster analysis. So I think it might be available here only. Okay, I think I will get back to you with this another time. Meanwhile, we'll see the another aspects, tools such as aspect. So aspect also, we have to select the layer which is in meter. And then after you can save as a aspect and run. So now if you see, now it has become the aspect. Now aspect value is ranging from 0 to 360. Okay, now aspect, what does it shows? Anyone? What do you mean by aspect?
Direction of slopes.
Yes, direction of
Slope.
slope. So now how it will help you? For which kind of application we can use this aspect? So in the previous classes, sir has told that we can use this for like when we have higher regions, then we can, if we know the angle, like where the slope is heading. So how much precipitation will happen in that particular area, or how the glacier will melt, how basically the sunlight is coming at that face and directly hitting. Then in case of solar also we can use the same thing. Okay, so we can use that for purpose. And now you can see here the values are from 0 to 360, means 0 is north and 360 is again coming to the north only. So now if I want to like see the thing in the different direction basically, so like basically the north, northeast to northwest kind of slopes. So how we can see that? So for that also we can do the reclassification by table, and then after here in table we will add a different rows. So first of all what will happen that 0 to, let's say, if I want to make a classification in just 4 direction, so basically it is not like 0 to 90, 90 to 180, because when we are talking 0, it's not a north direction. It's 0 to 90 is not a north direction. So 0 to 45 this side and 45 this side, which will be a north direction. So I can write like this: 0 to 45. And similarly what I will do is I will take 360 and I will remove uh, minus 45 from that. So 315 to 360 is also north direction. So north I am writing as a 0. Now after 45 we'll go with 45 to, we'll just add how many? Every time we will add 90 points. So 45 into 90, so we'll get 135, which will be my east direction. Then 135 plus 90, so 225 will be my south, 225 to 315, that will be third. I think this will write in and only. So 315 to 360, which is again north. So we have made a quadrant like this, and then I will click on OK and run my OK. 0, 1, 2, 3. It's not good. Okay, we have kept the other columns as it is. Sorry. So this are kind of things you will also face when you do the analysis. You are doing right only, but this error comes because it needs some parameter. You are not providing those parameters. Okay. So now this is the reclassified aspect. And now again we want to calculate the individual class wise pixel value, that how many pixels are facing a north. So I think I got the answer. So the tool name is unique raster layer unique value reports. So I can take the reclassified rasters unique value reports, or whatever name with you want to save, and you can save that, see the thing here as well. So you can see value 0 and pixel area, pixel count. So slope with 0, which is north slope, east slope, south slope, and west slope. So highest number of pixels are having, maximum number of pixels are having a slope towards the west direction. Okay, and its area is like this. But if you see, like, this change in area is not that much. So overall the site has most or distributed, like all the slopes are distributed. Similarly, now we will check the same thing for the previous uh, analysis also, which we did, which is for slope. So I think we'll check the layer of slope reclassification, and we'll generate a file for that also. So you can see here, like, okay. So you can see the, like, steep slope is very less, then uh, very high slope, moderate slope, and then low slope. Okay, so you can see the how much portion percentage of area has very steep slope. So by, if you want to write down that, you can take sum of it, 422 divided by sum of it into 100. So basically you also know the total pixel also, which is 70266. So if I want to say how many pixels are having, or how much area has have steep slope, so 422 divided by 40266 and into multiply by 100 I will do. So around 0.6% pixels or 0.6% area has very steep slope or steep slope, according to whatever the classification that you have made. Okay, so this is the aspect and slope. Now we do have some other tools also in raster terrain analysis, such as hillshade. So hillshade also you use your the layer which is in meter, and then this azimuth and vertical angle represents the angle of sun, that horizontal and vertical angle of sun. And then you save your file and then run it, and you will get the hillshade like this. And like we have learned in the previously also, that if you want to make it cool or looks good, then you can use the its elevation and superimpose on top of it. So this is the elevation which I have for that layer. Keep the hillshade bottom layer up, changing the transfer symbology. And then after changing the like transparency, reducing it by T. Now you can see the 3D effect, which is visible quite, and you can visualize it very good. Now the same thing, like in the hillshade which you have generated, if you need a lot of exaggeration, then what you can do is so instead of z factor 1, you can use a z factor of 3. So you will see the exaggerated values bit high. So it will exaggerate your elevation by 3 times, 5 times, and based on that it will show the same value. And so that you can see now, you can see the difference between these two, but it is not that much because main layer which we are seeing is the top layer. So you will not see that difference, but if you compare these two, you will see how they are different. Okay, and now what will happen if you use the layer which is in degree? So we'll do that as well. So this is the original layer which is in degree, and if I will run it, it will produce the result, but it will not be popular or like proper. So you can see here, you can see a lot of, you can see the hills, but a lot of noise you will see. And basically now let's say I think we did it for entire region, so we'll do it for the clipped region only. So you will get something like this, very noisy, if your data is in degree. So if your data, like, first step is to convert your data in meter, then and then only you will get something like this. Okay. So whenever you have data, DEM data, working with the DEM data, and you want to do analysis such as slope, aspect, or hillshade, first convert your data from degree to meter, and then after converting into meter, do the further operations, whatever you do. If you want to make into different classes, then you can use the reclassification tool. And for projecting from degree to meter, you can use WARP tool, WARP, and then these are the subsequent tools which we have learned in this class. So any other question on this or any other question from anything else?
So, may I ask one question regarding the
Yes.
hypsometric curves? What is hypsometric curves, sir?
So that will show the how your area is changing when you are going from uh, upstream to downstream. So I think next week also we can take that and I can show you in detail like how to plot the hypsometric curve if you are okay with that.
Yeah, yeah, yeah.
Yeah.
Another
So
another question was regarding
yeah. So
what are the
hypsometric, yeah,
vector
hypsometric
what are the
curves.
vector tools for terrain analysis?
What are the
Vector tools.
Okay, so for terrain analysis, generally it's a raster data, so we do not have much tools available, but we can combine the vector tool and do the analysis, such as zonal statistics. So if I have vector data, let's say I have DEM of region, and then I have vector data of different districts or sub districts or village. Now I want to aggregate the average elevation value or highest elevation value for all those villages. Then in that cases, I can use this zonal statistics tools where it will uses raster as well as vector data. So input data will be a raster like vector and then the raster leaf. And then it will perform any statistical summary which you are interested in and it will give you the statistics.
Yeah, thank you.
Yeah. So
Regarding the
yeah.
urban land use,
Yes,
uh, can I use the raster terrain analysis tools?
raster terrain analysis for which purpose? Land use what?
Urban land use, particularly, I am interested to use this particular tool for valuation purpose. So I want to develop tool for that.
Okay. So for that you can use raster terrain analysis, but the only thing is you need very high resolution data if it is for a estate purpose or something because in 30-meter data it is very difficult to see what is happening at street level.
Yes, yes, absolutely.
Okay,
And
so
on the left hand side, I can see S3 imagery. So
which
can we use
yeah, Isri, yes, yes.
can we use ArcMap or ArcInfo kind of the
Yeah, I mean, see,
softwares?
if you are interested in like seeing and digitizing by yourself, this is the resolution of ICRI imagery in QGIS. Okay. Apart from that,
Yeah.
here also you will have vector tiles is also available within this HCMGIS plugin. So if you use this HCMI plugin, here vector tiles are there. In that you will get the OSM and street view also. So basically the good thing about this is like if you use this OSM street mark, you can see this boundary in a vector format
Oh,
like this.
yeah.
So it will be easy. Like it will be not available for everywhere, but you can explore this thing because this data is vector. So it will be very helpful in digitizing if you are interested.
Great.
So
Thank
this
you.
map,
Thank you a lot.
yeah, these maps are available lot of from different companies like ISRI also, Topo Shades, OSM standard maps, street maps. Then this Carto Basic Dark. There's those maps are also available. So you can try which one is fine. Carto Basic is also a good one. Anyone has this thing. Okay.
Yeah.
Uh,
Thanks.
yeah, the hypsometric part we'll take in the next class because we don't have time. We're not able to finish it.
Yes, sir. Yes.
Okay. Any other questions? Anyone? Or if you want me to include anything for the next class, also you can tell me. You can also mail me on my mail ID if you are interested in learning something. So I got some queries last week also. I solved that in this week regarding the scale. So similarly, if you are interested in any other work, please let me know if it is possible to include within this class. I will surely do that. Okay. My email ID, this is my email ID. Also, you can write on NPTEL QA session window also. There also I will take from that as well. This is my channel. Or you can also comment on YouTube videos also. That is also fine. So with that, I think we can close this session. Thank you everyone for joining. Uh, we'll see you in the next week and keep submitting your assignment. Do not forget to turn it in. Otherwise, you will lose the mark. So do submit your assignments and I will see you in the next week. Thank you for joining. Bye bye.